common type of geometry proofs use congruent triangles and CPCTC. In this video, we'll look at how you can plan out what you'll need to do in order to use that theorem. For example, imagine I'm trying to write a proof for this problem where I am given that OP bisects angle MPN, MP is equal to PN, and I'm trying to prove that MO equals ON. You might wonder, where do I start and what's my strategy? As you try to make a strategy, I suggest you start from the end. Focus on what you're trying to prove. After you do a lot of proofs, you'll figure out that there's a pretty general format for these types of problems. So for example, imagine we're trying to prove a pair of sides or a pair of angles are equal. There are a couple different ways to do this, but depending upon the problem, you might be able to use CPCTC. That means corresponding parts of congruent triangles are congruent. Okay, if I want to use that, what do I need to know first? I need to know that the triangles are congruent. So we're going to go back to our first column. Now we need to prove that we have two congruent triangles. We have learned 4 ways to prove that any triangles are congruent. Side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse leg, which can only be used for right triangles. In your proof, you will have to have one of these before you can use CPCTC. Okay? In order to use our congruent triangles, in order to prove our triangles congruent, what will we need? Well, if you look at the names, you'll notice that we need 3 pairs of congruent parts. All of them include at least one S or one pair of sides. Then we'll need 2 other pairs. They might be sides or they might be pairs of angles. Now you need to ask yourself, how do I find those congruent pairs? Let's look at ways that we can prove that 2 sides are equal. This is where it's very helpful to remember your past geometry definitions. There are many ways that we know sides are equal. Some of the words we'll be looking for might be midpoint, bisector, or we might be looking for a reflexive side. That's in both triangles. If you don't remember these vocab words, take some time to go into the glossary or your textbook and review them. In order to use midpoint, bisector, reflexive, we're going to need to find these things from the given information. So that's the information that we are told when we start the problem. Or if we look at the picture, we can find that triangles overlap or share a side, and then we can use reflexive. If we were looking to find that 2 angles were equal, again, some of the options would include angle bisector, vertical angles, reflexive, or corresponding or alternate interior angles with parallel lines. Again, we can get those from the givens or from using the reflexive if the triangles overlap. Looking at the given is what we're told at the very beginning. The nice thing about that is we don't have to prove anything about the given. That's what we are flat out told is true. We always start by writing that down, and given will be our first reason. Let's do an example. Given OP bisects angle MPN, MP equals PN. Remember, in a proof, we start by writing down the givens, and given is our reason. So my first line, OP bisects angle MPN, MP equals PN. My reason is given. You'll notice that they already marked these equal sides on the picture by doing this little line on both sides. If they don't do that, you might want to draw that out on your paper and mark those equal. Or another thing I would like to do is I like to make a note, either mentally or by writing it down, about what kind of equal pairs I have. So right now, I have one pair of equal sides. Okay, now let's move to our next step. Remember, I said we need 3 pairs of equal parts. So 3 pairs of sides or 3 pairs of angles. If you don't know where to go next, you look at the given. In the given, they told us that OP bisects angle MPN. Usually, if you're told something in the given, you'll need to use it in your proof. Bisect means it splits into 2 equal parts. So that means that angle MPN was split into 2 equal angles. So I can look at the picture and find that those 2 angles would be equal. I'm going to write those down. So angle MPO is equal to angle OPN. How do I know that? Okay, it has to do with the word bisect. There are some different ways to write your reasons. Some people like to write it out as a sentence. An angle bisector splits an angle into 2 equal parts. You might also see this written just as definition of angle bisector. What you're doing is you're leaving a trail for other people that if they don't understand why those parts were equal, they could go and look up resources and figure out what an angle bisector means and how it helped you figure that out. So again, I'm going to write down what I just found. I just found a pair of angles that were equal. Okay, so I just wrote a pair of angles on the side. Remember, to make my triangles congruent, I need 3 pairs. So far I have 2. I used this part of the given, and I already marked down that. So I used the given information. Now I'm going to look for another common thing, which is to look if the triangles share a side or share an angle. I notice in the picture that those triangles share side OP. If I were to trace over both triangles, I would trace OP twice. So OP is the same in both triangles. Now remember, we're looking for equal pairs. So I'm going to have to write this as 2 equal sides. In the proof, I write down OP equals OP, and my reason is reflexive. This has just given me another pair of equal sides. Now I am ready to prove that those triangles are congruent. We named triangles with 3 letters. The first triangle, I could start in any order. So I'm going to call this top triangle, triangle MOP. Now the bottom triangle has to match up so that the corresponding pairs are in the same spot in the name. So triangle MOP is congruent to triangle NOP. My reason is based on what I wrote over here on the right. I have a pair of equal sides, a pair of angles, and then another pair of sides. And the angles are right in the middle. So my triangles are congruent by side, angle, side. We're not done yet. We wanted to prove that MO is equal to ON. Well, we know that because they're corresponding parts of congruent triangles. So my reason is CPCTC. What corresponding parts of congruent triangles means is think about if you have 2 cars that are the same brand, the same model. So you have 257 Chevys. Well, the individual parts of those matching cars would also be equal. So of the same model, the carburetor from one car is the same as the carburetor from the other car. So knowing that the models were the same lets you know that the individual parts are the same. That is what we were looking to prove, so we have finished our proof.